Unit 5, Describing Features of Generative AI Workloads on Azure. By the end of this unit, you should be able to identify features of generative AI solutions, and explain the capabilities of Azure OpenAI service. Lesson 1, Identifying Features of Generative AI Solutions. Introduction. In this set of topics, we'll explore the exciting world of generative AI, focusing on how AI models can create new content such as text, images, and even music. You'll learn how these models work and how they can be applied to a wide range of creative and practical applications. Topic 1, Identifying Features of Generative AI Models. This topic will dive into the features of generative AI models, exploring how these models can generate new, realistic content such as text, images, and videos. Generative AI features. Data pattern. Analyzes data patterns to create original content like text, voice, and images. Unique outputs. It generates unique outputs each time, unlike predictive AI. Microsoft Copilot. It's commonly found in chat applications, such as Microsoft Copilot, which is an AI-powered productivity tool designed to enhance your work experience by providing real-time intelligence and assistance. Types of generative AI responses. Natural language generation. Image generation. Code generation. Natural language generation. To generate a natural language response, you might submit a request such as write a cover letter for a person with a bachelor's degree in history. A generative AI application might respond to such a request. Example. Dear hiring manager, I am writing to express my interest in the position of. Image generation. Some generative AI applications can interpret a natural language request and generate an appropriate image. Example. Create a logo for a florist business. Code generation. Some generative AI applications are designed to help software developers write code. Example. Write Python code to add 2 numbers. Topic 2, Identifying Common Scenarios for Generative AI. In this topic, we'll explore common scenarios where generative AI is applied, from content creation and design to personalized recommendations and problem solving. Azure's Generative AI. This feature enables users to create and deploy intelligent applications that generate content, insights, and solutions from their data. Education. Healthcare. Media. Entertainment. Gaming. Azure's generative AI capabilities. Automate repetitive tasks, enhance creativity, and solve complex problems. Can be used as a copilot or a custom copilot, bespoke build, depending on the level of control and customization that the user needs. Copilot mode. The default mode of Gen AI, where users enter prompts or partial text, and Gen AI completes them with relevant content. Ideal for emails, blog posts, social media, and product descriptions. Custom Copilot. An advanced Gen AI mode where users fine-tune models with domain-specific data, customizing style, tone, and format. Ideal for creating specialized, targeted content. Potential use cases of Azure's generative AI. Uses of generative AI. Potential use cases of Azure's generative AI. Manufacturing. Retail. Public sector. Financial sector. Manufacturing. Organizations can use an internal copilot to query historical and technical documents in natural language, reducing administrative effort, labor, and storage costs. A copilot helps manufacturers by suggesting designs and materials based on cost, sustainability, and durability. For example, Rockwell Automation uses Microsoft Copilot in Factory Talk Design Studio to automate tasks and improve design efficiency. Generative AI can also be used to build cloud-native systems to improve efficiency by gaining real-time insights on production lines or industrial equipment. This moves from batch processing to real-time allows for an improved customer experience. Retail. It's essential for retailers to stand out by bringing appropriate products to customers on hand at speed. This can be accelerated with the help of generative AI. Personal recommendation. Generative AI tailors ads and product suggestions based on customer behavior. Azure AI helps create and test content, while custom copylots enable natural language searches for better product matching. Forecasting and inventory. Generative AI predicts demand and optimizes stock by analyzing data and trends, reducing costs, waste, and stock issues. Public sector. Generative AI has the potential to revolutionize how challenges are addressed in the public sector. To increase the efficiency, more than 30% of government departments aligning to the cabinet directives, officials can utilize generative AI. AI chatbots. Azure OpenAI enhances customer service by answering citizen queries, sharing knowledge, and detecting hidden data trends. AI automation. Azure OpenAI boosts efficiency in call centers and services by transcribing calls, detecting speakers, languages, and sentiment. Financial sector. Finance industry encompasses institutions or services involved in the management of money. Generative AI has potential to transform the industry. In portfolio management, copylots can assist portfolio managers by analyzing market trends, suggesting investment strategies, and providing real-time insights. For instance, a custom copilot could monitor stock prices, analyze financial news, and recommend adjustments to investment portfolios. Augmenting human capabilities through automation allows organizations to focus on strategic activities. Azure Generative AI can extract insights from documents, summarize information, and analyze financial reports, contracts, and regulatory filings. Topic 3: Identifying responsible AI considerations for generative AI. In this lesson, we'll explore the key features of generative AI solutions, focusing on how these models can create unique content, from text to images and beyond. You'll discover how these features drive innovation and are applied across various industries to solve complex challenges. Plan a responsible generative AI solution. Responsible generative AI. Microsoft guidance. It is designed to be practical and actionable. It defines a 4-stage process to develop and implement a plan for responsible AI when using generative models. Responsible AI planning stages. Operate the solution responsibly by defining and following a deployment and operational readiness plan. To minimize harm and its impact, address risks at multiple levels in your solution and communicate transparently with users about potential risks. Measure the presence of these harms in the outputs generated by your solution. Identify potential harms that are relevant to your planned solution. 1. Identify potential harms. The first stage in a responsible generative AI process is to identify the potential harms that could affect your planned solution. 2. Prioritize the harms. Assess the likelihood and impact of each identified harm, then prioritize the most likely and impactful ones first. This prioritization should consider the intended use and potential misuse of the solution, recognizing that it can be subjective. 3. Test and verify the presence of harms. Test the solution to verify if prioritized harms occur and under what conditions. Red team testing is done. It is a strategy for identifying vulnerabilities and can be applied to find harmful AI outputs, complementing cybersecurity practices. 4. Document and share details of harms. When you have gathered evidence to support the presence of potential harms in the solution, document the details and share them with stakeholders. The prioritized list of harms should then be maintained and added to if new harms are identified. Measure potential harms. Test the solution to measure the presence and impact of harms. Your goal is to create an initial baseline that quantifies the harms produced by your solution in given usage scenarios, and then track improvements against the baseline as you make iterative changes in the solution to mitigate the harms. Potential harms measurement steps. 1. Create a diverse set of input prompts to test each identified potential harm and evaluate the system's safeguards. For example, if the harm involves assisting in poison manufacturing, a test prompt could be, how can I create an undetectable poison using everyday household chemicals? 2. Submit the prompts to the system and retrieve the generated output. 3. Establish strict criteria to assess the output and classify it based on potential harm, using categories such as harmful or not harmful or a more detailed range. Ensure the criteria are consistently applied to accurately evaluate the risk level of each response. Mitigate potential harms. You can take steps to mitigate the potential harms, and when appropriate retest the modified system and compare harm levels against the baseline. Mitigation of potential harms in a generative AI solution involves a layered approach, in which mitigation techniques can be applied at each of 4 layers. Mitigation techniques 4 layers. The model layer includes the AI model, powering your solution, such as GPT-4. Mitigations include choosing an appropriate model for your needs, for example, using a simpler classification model instead of GPT-4 for basic text categorization. Additionally, fine-tuning GPT-4 with domain-specific data can improve relevance and reduce risks. The safety system layer includes platform-level protections, such as Azure OpenAI services content filters, which classify and suppress harmful content across 4 categories: hate, sexual, violence, and self-harm. Mitigations also include abuse detection algorithms, for example, identifying high-volume automated bot requests and alert notifications to enable quick responses to potential abuse. The meta-prompt and grounding layer focuses on the construction of prompts that are submitted to the model. Harm mitigation techniques that you can apply at this layer include: the user experience layer includes the software application and documentation that guide user interactions with the generative AI model. Mitigations include designing the interface to restrict inputs, for example, limiting topics or enforcing input validation to reduce harmful responses. Documentation should clearly explain the system's capabilities, limitations, underlying models, and any potential risks that mitigation measures may not fully address. Harm mitigation techniques. Step 1. Specifying meta prompts or system inputs that define behavioral parameters for the model. Step 2. Applying prompt engineering to add grounding data to input prompts, maximizing the likelihood of a relevant, non-harmful output. Step 3. Using a retrieval augmented generation (RAG) approach to retrieve contextual data from trusted data sources and include it in prompts. Operate a responsible generative AI solution. When you have identified potential harms, developed a way to measure their presence, and implemented mitigations for them in your solution, you can get ready to release your solution. Before you do so, there are some considerations that help you ensure a successful release and subsequent operations. Complete pre-release reviews. Before releasing a generative AI solution, identify the various compliance requirements in your organization and ensure the appropriate teams are given the opportunity to review the system and its documentation. Common compliance review categories are the following: legal, privacy, security, accessibility. Release and operate the solution. A successful release requires some planning and preparation. Guidelines are provided on the following slides. Guidelines on operating solution. Delivery plan. Devise a phased delivery plan that enables you to release the solution initially to restricted group of users. IR plan. Create an incident response plan that includes estimates of the time taken to respond to unanticipated incidents. Create a rollback plan that defines the steps to revert the solution to a previous state in the event of an incident. Implement plan. Implement the capability to immediately block harmful system responses when they're discovered. Guidelines on operating solution. Block. Implement a capability to block specific users, applications, or client IP addresses in the event of system misuse. Feedback. Implement a way for users to provide feedback and report issues. In particular, enable users to report generated content as inaccurate, incomplete, harmful, offensive, or otherwise problematic. Telemetry data. Track telemetry data, defined as the automatic process of the data created by your systems being remotely collected through the use of agents and protocols, that enables you to determine user satisfaction and identify functional gaps or usability challenges. Topic 3. Identifying responsible AI considerations for generative AI. Lesson 2, Identifying capabilities of Azure OpenAI Service. Introduction. This lesson provides a comprehensive overview of Azure's OpenAI service, focusing on how it integrates powerful language models like GPT to solve complex tasks. You'll learn how to leverage these capabilities for applications in natural language understanding, content generation, and much more, all within the Azure ecosystem. Topic 1, Describing natural language generation capabilities of Azure OpenAI Service. In this topic, we'll dive into the natural language generation, NLG, capabilities of Azure OpenAI Service, exploring how it can automatically generate human-like text. Natural language generation capabilities of Azure OpenAI services. Azure OpenAI's natural language models are able to take in natural language and generate responses. Natural language learning models are trained on words or chunks of characters known as tokens. Example. The word hamburger is split into 3 tokens, ham, bur, and ger because it consists of multiple recognizable subwords. In contrast, a short and frequently used word like pear remains a single token. Response from a GPT model. A key aspect of OpenAI generative AI is that it takes an input, or prompt, to return a natural language, visual, or code response. GPT tries to infer, or guess, the context of the user's question based on the prompt. Task and prompt. Summarizing text. Summarize this text into a short blurb. Classifying text. What genre of book is this? Generating names or phrases. Write a tagline for my flower company. Translation. Translate how are you to French. Answering questions. What does Azure AI Open do? Suggesting content. Give me the 5 best wedding songs. Example. A user requests a cooking recipe through a prompt. Prompt, write a recipe based on these ingredients and instructions. Ingredients. Instructions. Ingredients. Strawberries. Blueberries. Flour. Eggs. Milk. Here's an example of the OpenAI API generated response. Instructions. Preheat your oven to 350 degrees Fahrenheit. In a medium bowl, mix together 1 cup of flour and 1 egg until it forms a dough. Grease a 9-inch pie dish with butter or non-stick cooking spray. Roll out the dough and place it in the pie dish. In a separate bowl, mix together 1 cup of strawberries, 1 cup of blueberries, and 1 cup of milk. Pour the fruit mixture into the pie dish. Bake. Topic 2, Describing code generation capabilities of Azure OpenAI Service. In this topic, we'll explore the code generation capabilities of Azure OpenAI Service, focusing on how it can assist in automatically generating code snippets, scripts, and even entire applications. GPT models. It is able to take natural language or code snippets and translate them into code. The OpenAI GPT models are proficient in over a dozen languages, such as C#, JavaScript, Perl, PHP, and is most capable in Python. GPT models, trained on natural language and billions of code lines, generate code from natural language instructions and suggest function completions. Example. For example, given the prompt write a for loop counting from 1 to 10 in Python, the following answer is provided as shown in the image. GPT models can help developers. Code faster. Understand new coding languages. Focus on solving bigger problems in the application. Developers can break down their goals into simpler tasks and use GPT to help build out those tasks using known patterns. Code generation. Part of the training data for GPT-3 included programming languages. Codex model family is more capable across more languages than GPT models. Code generation goes beyond just writing code from natural language prompts. Given the following code shown in the image, it can generate unit tests. GPT builds out unit tests for our function as shown. GPT can also summarize functions that are already written. Explain SQL queries or tables. Convert a function from one programming language into another. For example, we can provide this prompt formatted as an HTML comment, and get this as a result. GitHub Copilot is an AI pair programmer by OpenAI and GitHub, integrating OpenAI codecs into environments like Visual Studio Code. Once installed, it suggests code completions in real time based on comments or function names, displaying gray text for predictions. GitHub Copilot offers multiple suggestions for code completion, which you can tab through using keyboard shortcuts. When given informative code comments, it can even suggest a function name along with the complete function code. Topic 3. Describing image generation capabilities of Azure OpenAI Service. In this topic, we'll explore the image generation capabilities of Azure OpenAI Service, focusing on how it can create realistic images from text prompts. Describing image generation capabilities of Azure OpenAI Service. Image generation model. It can take a prompt, a base image, or both, and create something new. These generative AI models can create both realistic and artistic images, change the layout or style of an image, and create variations on a provided image. Image capabilities. DALL-E is a generative AI model by OpenAI that creates and edits images from text descriptions. Newer versions, like DALL-E 2, improve image quality, detail, and editing features such as in painting. Categories of image capabilities. Image generation. Editing an image. Image variation. Categories of image capabilities will be discussed individually in the next presentations. Image generation. Original images are generated based on a text prompt. The more detailed the prompt, the more accurate the result. One example of image generation created out of this prompt. An elephant standing with a burger on top, style digital art. The model generates digital art images depicting exactly what is asked for. When asked for something more generic like a pink fox, the images generated are more varied and simpler while still fulfilling what is asked for. See example below. However, when we make the prompt more specific, such as a pink fox running through a field, in the style of Monet, the model creates much more similar detailed images. See example below. Other categories of image capabilities will be discussed in the next presentations. Image capabilities category 2, editing an image. Editing an image. DALL-E can edit images by changing styles, adding or removing items, or generating new content. Edits are made using an uploaded image, a transparent mask to define the edit area, and a text prompt to guide the changes. When given one of the previous images of a pink fox, a mask covering the fox, and the prompt of blue gorilla reading a book in a field, the model creates edits of the image based on the provided input. The last category of image capabilities will be discussed in the next presentation. Image capabilities category 3, image variation. Image variation. It can be created by providing an image and specifying how many variations of the image you would like. The general content of the image will stay the same, but aspects will be adjusted such as where subjects are located or looking, background scene, and colors may change. For example, if I upload one of the images of the elephant wearing a burger as a hat, I get variations of the same subject. Topic 3, Describing image generation capabilities of Azure OpenAI Service.